Okay, so in this video, we're going to go over constructions. And first we need to construct two congruent triangles. Then we're going to prove that the two triangles are congruent. And then for 3a and 3b, we're going to construct an angle bisector and a perpendicular bisector. So let's go ahead and start with 2a and 2b. So for 2a, they ask us, they just ask us to to construct two two congruent triangles. The ones that I'm going to construct are equilateral because I think they're kind of sophisticated and cool to use here. So let's go ahead and start. So the first thing we need to do is get a straight edge. Now I don't have a ruler, so I'm going to be using this as my straight edge. And we're going to start by basically drawing a straight line here for the sake of space. I'm going to put this up here. Hope you can see this. Hope it comes out clear. Okay, and then on the corner I'm going to write 2A. Okay. And this might not be too clear. Okay, that's probably better. Adjust the zoom here. Hope that comes out. Okay. So we're going to start by drawing a line about that length. It doesn't have to be super long or short, just a line of approximately that length. Now this length is arbitrary. There's actually nothing really special about it. Here, maybe if I do this, it's better. I want to make sure you can see that. Alright. So this is an arbitrary length. What I'm going to do next is I'm going to get my bow compass and I'm going to adjust it, and you can do this with your compass as well, so that I can put the tip of the compass on one endpoint and the pencil point on the other endpoint. So I'm going to try and see if the camera can capture this. Hold on. We want it to look more or less like this. See if I do that here. Yeah. So you see how I have the point on one endpoint, the needle, and then on the other endpoint I have the pencil part. So I'm going to use that, and I'm going to draw an arc like this. Oh, this might be kind of hard to see because this is using a pencil. I should use one that has a. I don't have one with a pen though, so this is the best that we can do here. Okay, well you can see that. Yeah, it's not too light. Okay. All right, so that was step one. Now the next thing I'm going to do is I'm going to go ahead and now this time, the first time I put the needle on A and the pencil on B. This time I'm going to put the needle on B and the pencil on A. Notice I didn't change the setting, right? I didn't change the size, the width here, the radius in the compass. All I did is I just lifted it up, but I didn't change the actual radius. It must be the same. If it's not, then you don't get the correct picture. Alright, so I'm going to put it there, and I'm going to go ahead and try and do my arc here. Okay, hopefully that comes out. I'm going over it multiple times so that it gets darker. Okay, there you go. Very nice. So what I'm going to do next is, notice that the two arcs that I drew intersect. So I'm going to use my straight edge. Well, first I'm going to get where's my pencil? I just had it right now. Here it is. Okay, I'm going to name the point where they intersect right here. Let's call that point C. Now I get to use my straight edge, and I'm going to go ahead and connect these 2 points here. So A and C are connected. Okay, let me just zoom here. I feel like it's not. Alright, that's better. And then I'm going to do the same here and connect C and B. Alright. Go. Okay. Now you might be wondering, what did I just do? What's up with this triangle? Well, and we're going to write this for 2b, but for 2a I'm just going to explain what's happening here. What I've just done is I've constructed an equilateral triangle. You might be wondering, how does he know it's equilateral? Well, this distance AB is congruent to AC. So these two are congruent. Why? Because they represent the radius of the same circle, right? Which is represented by this little arc here, right? So AB and AC are on the circle, meaning that they're from the center to the edge, right, on the circle. So they're the radius, right? And whenever you draw a radius in a circle, they're all going to be congruent, right? So AB and AC are congruent. Now, over here, AB and CB are, guess what, are also congruent, because they're both the radius of this other arc that I drew over here, this other circle. Now, the two circles that I drew are congruent. They're the same circle. Why are they the same circle? Because they have the same radius. Remember I said, when I was drawing this, I said don't pick up the compass. Don't adjust the settings on the compass, right? You can pick it up, but we're not changing the width, right? That means that we're essentially drawing the same circle, right? Because it has the same radius. Wherever I draw, I can draw a circle over here, and guess what? It's going to be the same congruent circle because it's going to have the same radius. The only time it changes is if I start messing with the little wheel, right? This little wheel thing, and it's going to change the radius of the circle. So we know that AC, AB, and BC are all congruent to each other, which by definition it's an equilateral triangle, right? Because all sides are congruent. Now we're going to do the same kind of thing, but this time, notice I'm not changing the setting, right, on the compass. It's still the same radius here. So notice this time what I'm going to do is I have the needle on letter B and the pencil on A, but now I'm going to draw my circle on this side. So I'm going to do it over here. So I'm going to try and do this to where you can see it. No, it might not be clear, but okay. Or something like that. Okay. Alright. So I basically just continued the circle with at center B, right, with center B. What I'm going to do next is get my straight edge. And I'm going to line it up with the points A and B. And I'm going to go ahead and continue that straight line all the way to where it intersects with the little arc that we just drew. That little point where it intersects, we'll call that D. Okay. Now we're going to construct, in an analogous fashion, another triangle the way we constructed the first one here. So I'm going to put, this time the needle is going to be on D. I still haven't adjusted the settings or anything. It's still the same radius, right? And the pencil point is on B. And I'm going to go ahead and construct it this way. Hopefully this comes out. There it is. Alright, cool. And I'm going to go ahead and draw or plot a little point right here. And that's going to be E. That's the intersection of those two arcs. So again, I'm going to go ahead and construct a straight line through E and B. And construct a straight line through E and D. Okay. Alright. So, I have another triangle here. And we don't have to write this until, we should already jump to 2B, but I'll write it when I'm doing the 2B part. Here, let me just explain what's happening. So this radius, dB, right, of the circle, notice is the same thing as AB. Right, so these two are the same. What that tells us is that AB is congruent to BD. They're both the radius of the circle with center B. Right, if you imagine this is like one giant circle. Right, maybe I won't draw it, but you can visualize it as I spin compass around. So AB and BD are congruent to each other, and we can use the same reasoning to argue that BE is congruent to BD, and BD is congruent to ED. Therefore, BE, BD, and ED are all congruent to each other, and we already know that BD is congruent to AB, so then this is congruent to the ones over here. So then all of the line segments are congruent. So we have 6 line segments here. They're all congruent to each other. So we can use the side-side-side congruence theorem postulate to show that the two triangles are indeed congruent triangles. So I'm going to go ahead and kind of jot that out for B. Now I shouldn't be giving you the answer, so I'm going to kind of summarize it. And I'm going to do this in paragraph form. So we can start by saying that segment AB is congruent to segment AC since both are the radii of the same circle. And if you want, in parentheses, just to be, we can write arc, because that's what they used in the module. So we can write here arc, because these are basically the arcs that we're constructing. Okay. And then we know that, so that was AB is congruent to AC, right? Yeah, AB and AC. All right, good. So we also know that AB is congruent to BC. Okay, because they are also the radii of the same circle. All right. Using the transitive property, we can deduce that AC, segment AC, is congruent to segment BC. Okay. And that's using the transitive property. Because we said that this is congruent to this, and this is congruent to this, therefore this is congruent to this. Alright? Hence, triangle ABC is equilateral. Okay. I'm going to draw them like that. Okay. Alright, so we've established that triangle ABC is an equilateral triangle. Now we kind of use an analogous argument for the triangle on the right side. So here we're going to write segment AB is congruent to segment BD since they are the same radii of, they are the radii of the same circle. So that basically shows this. And then I want you to finish this part where we argue that BE and DE are both congruent to BD and therefore are all congruent to each other. So we basically have that. So I'm going to put fill in this part. I'll put it in like brackets, so kind of a side note. Fill in this part to show that triangle BED is equilateral and AB is congruent to BD, comma, sorry, I'm kind of writing it out for you, but you still have to fill it in and kind of clean it up a bit, this part. So we're going to use that AB is congruent to BD, AC is congruent to BE, and BC is congruent to DE. So we're going to kind of mention that there. And then the last part of the proof, basically the punchline here, is we say, therefore, or let's write it, yeah, well, we can write it like that. Therefore, triangle ABC is congruent to triangle BDE, and I should be naming these in the appropriate order. When I put here triangle bed, I think it's because it's already 12:30 and I feel like I need to go to sleep. So I'm subconsciously thinking of bed, but let's write it like this: BDE. Right? We're going in the same order like this, right? We're starting A, B, C. So then B, D, E. So it's got to be in the same. Sorry, I just realized I put that there. So triangle ABC is congruent to triangle BDE by side, side, side. So you can just put like by SSS. Or it's probably better to write it out. Alright? So we're done with 2A and 2B. So I put a little like QED or something here. Kind of cool. Alright. Now we can do, we're almost done here. We just need 3A and 3B. These are actually a lot shorter. 3A. Here we need to construct an angle bisector. Remember what an angle bisector was? It's a ray that cuts an angle into two congruent angles. Okay? So we're going to start this by drawing the angle first. So let's just draw an arbitrary angle. So let's do it like this. Okay, like that. And then, let me try it. Maybe something like that. Okay. And then this will call it point A. Then maybe somewhere out here we can call this point B. Point C. Notice these points are arbitrary. There isn't a special there's a special reason why I put B there and C there, right? The next part is important though, so you have to pay attention to this here. What we're going to do is we're going to get our compass and we're going to change the setting here and we're going to make it a little bit smaller width here, right? So I'll show you before I draw the angle. You see how this is shorter, right, than B, where the point B is? So I'm going to go ahead and draw an arc here. And this is kind of a big one because it has to cross both, basically both of these line segments. Alright? So what we're going to do is we're going to label these points. And ABC, so we use D here and then E here. Okay, so these are where the arc intersects with the line segment. Okay. So what we're going to do next is, and here we're going to change the setting, right? We're going to make our width a little, just a tad little bit shorter here. Okay, and again, it doesn't really matter how much shorter, just a little bit shorter. I'm gonna go ahead and draw a little arc here. Sorry. Notice I'm putting the the little needle on E, and I'm gonna try and draw this arc like that. Sorry, I'm trying to do this. This cooperates. All right, so hopefully you can see that, right? So I'm just doing a little arc like that. Okay. Then notice what I said, without changing the width, right, on the compass, or not changing the radius, I'm going to pick up the compass and put the needle now on D. And then I'm going to go ahead and draw an arc, trying to make sure, I need to make sure that it intersects with the arc that I just did right now, the previous arc. See that? So they kind of intersect there. So I'm going to go ahead and plot, or not, yeah, let's label this as point F. And then the last step is just to get our straight edge. And we're going to line up F and A, and then connect ray like that. And there you go. That's an angle bisector. That's all we need to do there. Then now we can do 3B, which is a segment bisector. Again, we're going to start off by drawing a arbitrary line segment. So maybe something like that. Label the endpoints. So we have A, we have B, and then now we're going to go ahead and get our compass. Put the needle on A. And then when we're doing the little pencil, can't see that, sorry. When we're placing the pencil, it's a little bit more than half of the distance from A to B. So just a little bit more. Okay, so on my picture, that looks good on the camera like that. Yeah, so a little bit more than halfway. And we're going to go ahead and, wait, let me make this a little clearer. So let me make sure that, alright. Okay, so now we're going to go ahead and do our arc. This time we make a big arc. So it's going to be like, almost like a semicircle. So make a big, kind of a big semicircle like that. Okay, I was a little excessive in mine. I made it a little bit too big, but that's okay. Alright. Now, we're going to not change the width on the compass. This stays the same. I'm going to place a needle on B, and then we're going to do the same thing and draw kind of like a semicircle. Let's do that like this. Alright, nice. Okay, so now we get these two new points where the arcs intersect. Call that C, and this one over here we'll call it D. And then the last step is connect the dots, basically. C and D, we're going to connect them using our straight edge. And we have officially made, if you want you can put a little point here, E. We've officially made our segment bisector. So this is 90 degrees, and it bisects the segment AB into AE and EB, and remember AE and BE are congruent by definition. And that wraps up our video